So we've seen limits in this form. Limit as h approaches 0, the function at a plus h minus the function at a all over h. And think about that graph that we've drawn over and over again. So we use these limits to find the slopes of a tangent to a curve. You do this when we are trying to calculate velocities and also in other rates of change. It comes up so often that we actually give it a special name and notation. We call it the derivative of a function f at a number a, and we denote it this way, f with a little apostrophe there. F at a, we say f prime at a. So pronounce this f prime at a. And what is f prime at a, or the derivative of f at a? It's the limit as h approaches 0 of the function at a plus h minus the function at a all over h, if the limit exists, okay, because it doesn't always. An alternate way of writing this definition, f prime at a, is the limit as x approaches a of f at x minus f at a all over x minus a. It's the same thing. Okay, so here's an example. If f at x is 2x squared minus 5x plus 6, that polynomial, find f prime at 4. That is, find the derivative of f at 4. Okay, so what is f prime at 4? And I think I will use this definition this time, and I'll use this definition for the next example. So f prime at 4 would be the limit as x approaches 4 of f at x minus f at 4 all over x minus 4. Okay, so I just substituted 4 in for the a value. Okay, if this is f at x, what is f at 4? Well, it would be 2 times 4 squared minus 5 times 4 plus 6, and collect everything up, I'm getting 18. Okay, so this is the limit as x approaches 4, f at x, and f at x is 2x squared minus 5x plus 6. Subtract f at 4, which is 18, all over x minus 4. Okay, and from here you're just simplifying your algebra. So limit as x approaches 4 of 2x squared minus 5x minus 12 all over x minus 4. Okay, so obviously if we do direct substitution in here, we're going to get a 0 over a 0. Well, maybe not obviously, maybe you got to think about that a little bit. But you're going to get 0 over 0. And then, so we're going to try to factor an x minus 4 out of the numerator so we can cancel. Okay, so since that's our goal, let's just do quick synthetic division and find our factors. So synthetic division, and a reminder of how to do this is you take your coefficients, 2, -5, -12, and we are hoping to find -4 as a factor, so that means +4 would be the root. Bring down the 2, multiply, add these together, multiply, add these together. Okay, so x minus 4 is a factor. What's the other factor? 2x plus 3 and x minus 4. And perhaps you could have just factored that in your head, but some of them are more complicated. So remember to use synthetic division when it helps you out, and it often does when you're doing these x approaches a definitions, because you're trying to factor out this binomial, and it gives you an idea as to whether or not that's going to work for you. Okay, so we've got this limit as x approaches 4 of 2x squared minus 5x minus 12, which factors as 2x plus 3 and x minus 4, and x minus 4. And common factors cancel, and we get this. The limit as x approaches 4 for 2x plus 3. And I can use direct substitution. I put 4 in for 2, and I get 8 plus 3 equals 11. Okay, so don't get lost in all that algebra. What was the question? The derivative of f at 4. F prime at 4 is equal to 11. What does that mean? It means that the slope of the tangent line to the parabola 2x squared minus 5x plus 6 at the point 4, 18 is 11. The slope of the tangent line to the curve, to this curve at this point is 11. F prime at 4 equals 11. It's giving you the slope. Of course, you could take it that, if you had to, and write the equation of the tangent line to the curve at the point. Why don't you try to do that? From substituting 4 in for x gave us a y value of 18.